Okay, welcome everyone. We will just wait for people to come into the room and then we will get started. We're expecting quite a lot of people here today, about 100 people here already. That's great. So we'll do some introductions while people are coming in the room and some preamble for our webinar today. So welcome to this New Directions webinar. I'm Richard Spivey. I'm the New Directions Conference Programme Chair and a researcher at the British Council. Welcome to our webinar today. Thank you for joining us. If you're not familiar with the New Directions Conference, here's a little bit of information about it. I'll give you some links to our conference website later on. So as you can see, New Directions is a language assessment conference of the British Council. It's our biggest, our main language testing and assessment conference. And we hope it provides perspectives and insights on trends and approaches in English language assessment at a local level within country, at a regional level within East Asia, and at an international level globally. It was established in 2013, and we've had 11 editions so far. Our latest was in Hanoi last year, so this will be our 12th edition, which will be in Bangkok in Thailand in November. And you can see the dates there, 21st to the 23rd of November this year at Chulalongkorn University. It's a face-to-face conference. We would love to see you there if you can make it. And the theme is on the power of language assessment on individuals and society. And the audience, the kind of people we will be expecting there are people such as language testing academics, policy makers about the language education in the region, and also education and testing practitioners. So those who make tests, those who provide language education, etc. And you can see two of our partners with the conference, Chulalongkorn University and Thailand TESOL, who are helping us with organisation and the venue. So these are the themes that we'll be looking at in the conference. So the overall theme is the power of language assessment, the impact of language assessment on individuals and society. There are 4 strands to this: the impact on learning systems and assessment, impact on society, the role of English alongside other languages, and also, which is relevant to our webinar today, technology and AI. So how, what are policies around AI and how is that being implemented in language assessment and language education? So this is the first coming to our webinar today, which is on the topic of AI. This is the first of our 3 webinars before the conference. I'll give you details about the others later. It will last about 40 to 45 minutes, and then we will have questions at the end. You can write your questions into the Q&A function, and hopefully you should be able to write any other comments or greetings into the chat function as well. And after questions at the end, I'll show you some more information about the next webinar and the conference in general. So let's get started with our webinar. I will introduce our speaker first. Dr. Mariano Felice is a senior researcher and data scientist for language assessment and learning at the British Council. His work involves looking at how artificial intelligence and natural language processing can be used to improve learning and assessment. Mariano is also a visiting researcher at the University of Cambridge, where he completed his PhD in computer science and worked as a research associate. He's now at the British Council, and he has worked on NLP for language assessment and has published widely in top-tier NLP conferences and is a regular speaker at international conferences as well. And his talk today is called Decoding AI, Empowering Stakeholders in Language Learning and Assessment Contexts. So I'd like to thank Mariano very much for joining us today and invite you, Mariano, to share your screen and your presentation.
Thank you very much, Richard, for the introduction. So let me get my slides on the screen.
Yep, we can see those. That's great.
Great. Well, good morning, everybody, or afternoon or evening, wherever you are. So in this webinar today, I will talk about how stakeholders in the language learning and assessment domain can gain the knowledge and tools they need to use AI effectively. And as we will see, this means understanding how AI works, what we can do with it, what we should be aware of, and when it is a good choice to use it. So we often hear that a crucial aspect of using AI successfully is by promoting AI literacy. So I would like to share with you some insights from 2 reports published in the last 2 years. This first graph shows the results of a small survey that comes from last year. This was done with teachers, administrators, and support staff in the US. When asked whether they felt prepared to use and oversee the use of generative AI tools in the classroom, only 15% of the respondents answered positively. So this means that there is an overwhelming majority of people, 85% of the respondents, who do not feel confident or fully prepared to let AI into their classrooms. Now, in this second graph, I'd like to show you the results of another survey on the use and perceptions of AI carried out this year by the British Council. This is a much bigger survey that included over 1,000 teachers from all around the world, so it is a lot more representative. Now, when these teachers were asked whether they have received enough training to incorporate AI into their teaching, only about 20% of them agreed. The remaining 80% has either a neutral view or disagrees with that statement. And if we focus only on the disagreements, we see that they amount to roughly 55%, which means that more than half the teachers in the survey are explicitly saying that they don't feel prepared to use AI in their jobs. So as you can see, there seems to be a clear need for AI literacy among professionals in the education sector. So hopefully this webinar will contribute to this goal. Now, we hear a lot about AI literacy, but we don't often hear what this means exactly. What are we expected to learn to become AI literate? As with many other key concepts, there are lots of different definitions, but I decided to focus on 4 that I feel are particularly important. So the first one is one of the most cited academic definitions, which states that AI literacy is a set of competencies that enables individuals to critically evaluate AI technologies, communicate and collaborate effectively with AI, and use AI as a tool online, at home, and in the workplace. So this is a definition that takes a very practical point of view, so to speak. The second definition is by UNESCO, and it defines AI literacy as a combination of 2 other types of literacies. Data literacy, which is about understanding how data is used by AI, and algorithm literacy, which is about how algorithms find patterns in that data. And this seems to be a much more technical definition in comparison. The third definition I wanted to show you is included in the European Union's Artificial Intelligence Act, which was passed last year, and it defines AI literacy as the skills, knowledge, and understanding that allow providers, deployers, and affected persons, and blah, 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 to make informed deployment of AI systems, as well as to gain awareness about the opportunities and risks of AI and possible harm that it can cause. So in the same vein, we also have a definition by the Artificial Intelligence Literacy Act of 2023 by the United States Congress, which defines AI literacy as the skills associated with the ability to comprehend the basic principles, concepts, and applications of artificial intelligence, as well as the implications, limitations, and ethical considerations associated with the use of artificial intelligence. So we can see that in these two very similar definitions, they introduce the concept of skills, understanding, and very importantly, ethical implications, a concept that was not mentioned in the previous definitions that I showed, but has become very, very relevant nowadays. Other authors sometimes also make distinctions between literacy, meaning only the knowledge about AI, and competence, or the ability to actually use these AI tools. However, I prefer to use a more overarching approach that considers both aspects. Now, what do we expect from AI literacy? How can it help different stakeholders? So let's have a look. First, it can help make informed decisions about adopting and integrating AI tools in different settings, making sure that they are suitable solutions and align with educational goals and ethical standards. Second, it can help ensure that we maximize the benefits of AI, using it in ways that save time, money, resources, and so on. Third, it raises awareness of the limitations and potential risks of AI, allowing different stakeholders to adopt risk mitigation strategies, for example, to avoid biases. Likewise, AI literacy is necessary to promote a responsible and ethical use of AI, emphasizing the importance of crucial aspects such as transparency, accountability, security, privacy. And finally, AI, as AI continues to evolve, the more we learn about how these technologies work, the better prepared we'll be when new technologies appear. So to make these points clearer, I have also included some examples of this, what these benefits would mean for different stakeholders on this slide. And I should also mention that when it comes to AI literacy, it is often agreed that the kind of literacy that is needed is not the same for all stakeholders. So, for example, people who use AI more sporadically or casually would not require the same level of understanding and skills as someone that, for example, uses AI frequently or uses it in high stakes scenarios. So AI literacy should be tweaked to the needs of different stakeholders. When it comes to how AI literacy should be put into practice, there's no single agreed framework. Different organizations in the public and private sector, as well as academic institutions, have different proposals on how to approach AI education, mostly based on advice from experts and empirical research. But also many countries also have their own educational policies to integrate AI into school curricula, for example. So it is expected that in the future, most people would have access to AI education from a very early age. AI literacy frameworks can also vary a lot in terms of goals and scope. Some of them specify as many as 10 different skills, for example, that individuals are supposed to develop to interact with AI systems successfully, while there are other frameworks that just limit this set of skills to just a few. And one of these simple approaches that I think summarizes the expectations of AI literacy very well is one I'm showing here on this slide. This is by a non-profit organization in the United States called Digital Promise. And in the framework, AI literacy includes the knowledge and skills that enable humans to critically understand, evaluate, and use AI systems. Three concepts that I think embody the goals of literacy very well. So without really following the framework to a T, I will use these three concepts as guiding principles through the rest of my talk today. So the first thing that we should aim to do before using AI systems is to understand what they are and how they work. And these will allow us to be realistic about their capabilities and limitations and use them critically. Now, before I go into the details of how systems work, it's essential, I think, that we know what we mean when we talk about artificial intelligence, especially since nowadays people seem to associate AI almost exclusively with generative AI, and they tend to use both terms indistinctively. But the truth is that AI is much more than ChatGPT and has existed long before ChatGPT came into existence. So I think it's worth reminding ourselves of what AI is. So this is a definition that I particularly like. It says artificial intelligence is the ability of computers to perform tasks that are typically associated with human intelligence. And what this means is that these tasks are tasks that typically require understanding, reasoning, or inference. They are not just numerical calculations, even though there are lots of numerical calculations happening in the background. AI can be created in lots of different ways. The first AI systems were created using what we could call symbolic approaches, where all the knowledge required to solve a task was explicitly encoded using formalisms such as first order logic, for example. These were systems that typically used rules. They were rule-based systems. These were rules that were manually created by experts and AI practitioners together. And all these rules would make up the intelligence of the system, right? So one example could be a system, for example, that would diagnose diseases based on symptoms. So you would have doctors, for example, that would help you write the rules that would be required to diagnose these diseases. However, from the 90s onwards, we started seeing the emergence of what are called data-driven approaches, and most precisely machine learning, which allows us to build AI systems using examples, not having to define all the logic of the system explicitly. Instead of specifying the way in which the system should solve a task, we would feed the system with lots of examples, and the machine would learn patterns and associations by itself that would then allow it to solve new and seen cases. A very common example in educational domains is automated scoring, where we give the machine lots of essays with corresponding scores, so it can learn to predict how to assign a score to a new and seen essay. Most of the time, the input to these models are a piece of text, for example, an essay, but it could also be an image, for example, a photograph, or audio, such as somebody's speech, or something else. But there's a problem with this approach. Machines don't understand text or images or audio or video. They only understand numbers. So we need mechanisms to convert all these non-numerical input, such as an essay, into a numerical representation that the machine can understand. One way of doing this is by using features that are defined by humans. Another way is deep learning, called deep learning, where numerical representations are instead automatically computed by the machine. So let's have a look at these two approaches in more detail. When we use features, we define a number of meaningful things that we can compute from the input and use that as the new numerical representation that we need for the machine. So in the case of essays, for example, we can compute things like the total number of words, or total number of sentences, number of words that have a particular part of speech, type token ratio, or anything else that we think is informative to represent an essay. All those numbers that characterize one example, in this case, one essay, are packed together into what we call a feature vector. And we use that numerical list of numbers as the equivalent, the numerical equivalent of the non-numerical input that we have in our system. However, in the last decade or so, we have also seen another way of converting this non-numerical input into numbers that a machine can understand. And this is an approach that's called deep learning, as I mentioned. And in this approach, a machine can transform any input into a set of numbers automatically without the need for human intervention. So there's no need to define these features manually. The machine will figure them out by itself. Now, the problem with this approach is that the numbers that make up this new numerical representation have no meaning to us humans. So unlike the features that we define ourselves, we can't really make sense of all these numbers that are derived by machine learning. They only make sense to the machine. So that's the reason why we tend to call this approach a black box, right? But the truth is, however, that they work very well, and typically they work much better than feature-based approaches. So that's why they tend to be used a lot more now for more complex problems. Now, let's have a look at how we typically build a machine learning model. So we first start with a data collection phase, where we collect examples with the labels. So in the case of essay scoring, this could be essays and their corresponding scores. We then pre-process that data to remove things that we don't want, like, for example, we could remove images that we have in the essays, or fancy fonts, or anything else that is not really important, and we only keep the text. And we convert, as I mentioned, all these non-numerical input, all this text, into a numerical representation that the machine can understand using one of the two approaches that I mentioned earlier. Then we use that nicely formatted data to train the machine using an algorithm that's basically a program that finds the relationships between the numbers that we had in each example and the corresponding labels. So in this case, it would try to find the associations between that numerical representations that we generated and the scores, right? We also often tweak some parameters when we do training, in the hope that we can achieve better results, because in general, the first model that we build is not necessarily the best one. And once we finish with tweaking, we go to another phase, a testing phase, where we use some data that we set aside to compute an evaluation metric. And this could be something like accuracy, for example, and will allow us to say that, I don't know, our system has, for example, 80% accuracy or so on. So once the model is ready, we can use it in the real world to solve new unseen cases. So in the case of essay scoring, score new essays. So here is a more visual representation of the same process that I described earlier. And the process is basically the same for all sorts of different tasks. What changes is often the algorithms that we use, the data representations, and the learning strategies. So this means that things like face recognition, machine translation, or text-to-speech, they all follow the same principle of training. Deep learning approaches use a special kind of model called neural networks that are inspired by the way that our brains work. And I'd like to define exactly what these neural networks are. So a neural network is a model that consists of nodes that we call neurons that are basically all interconnected. They could be interconnected in many different ways. Each of these neurons receives input from other neurons, processes that input, and then produces output that is sent to other neurons. So that output, the output from each of these neurons, is then used as the input to other neurons. These neurons are generally arranged into layers. So we have different stacks of layers. So there's an initial input layer, for example. Then we have one or many hidden layers. And finally, we have what we call an output layer. So whenever we feed input into this network, that input will be processed by the input layer and that be passed on to the rest of the layers until we receive it on the other end on the output layer. And that's where we get the result of the process. In general, the bigger the network with more neurons and layers, the more the network can solve more complex problems. And networks with two or more hidden layers are what we call deep neural networks, and are what form these deep learning approaches that we use nowadays. And as I said, for other algorithms as well, we can use neural networks to solve all different kinds of tasks. And nowadays are mostly the dominant approach for any complex problems. Now, to give you a more concrete example of how this would work in a practical application, let's suppose we want to build a system that predicts, for example, whether someone is likely to pass or fail an examination based on their performance, for example, on a written assignment. So the text of that assignment would be the input to the network. The input layer would transform the text into a numerical representation, as I explained earlier. And then the hidden layers would take that numerical representation, try to find patterns and associations between those numbers and the expected output, in this case, a pass or fail. And finally, the output layer will activate the neuron that corresponds to the output. So in this case, it would say whether somebody would pass or fail. So that neuron that corresponds to the output would be activated. Another popular term nowadays is LLMs, or large language models. These large language models are basically supercharged versions of traditional language models. So there would be something like language models on steroids, basically. So in their most basic form, these language models are essentially models that predict the next word in a sequence. So if we give it the sequence, I would like to something else, then we will expect the model to give us a list of all possible words that could come after that sequence, generally sorted from the most probable to the least probable. And these models are very crucial for a lot of applications in AI. For example, speech recognition or grammatical error correction, as they tell us a lot about what sentences look more likely and sound more natural. So these are really foundational models within AI. Now, in the last few years, however, new language models have started to be trained using massive amounts of data from the internet, and also tweaked to understand how to follow instructions. So this gives them the ability to solve tasks beyond next word prediction. Although that's something that is still essentially what they do. They basically predict the next word, and that's how they produce their final output. So as I'm sure you know and you've seen, these large language models like ChatGPT or Gemini, they generate output based on a prompt or a set of instructions given by the users, and the quality of the prompt that we create has a direct impact on the output that these models produce. So essentially, the better the models that we write, the better the prompts that we write, the better the results that we're going to get. And this is a skill that is now known as prompt engineering. So in other words, how to write good prompts to get the results that you want from a language model. So now that we've learned a bit about how AI models are created, let's see what we can do with them. So broadly speaking, we can use AI for two purposes, prediction and generation. So by prediction, I mean labeling or transforming some output that we receive. So this includes things like classification of things in the input. For example, pattern speech tagging or regression tasks like predicting the score or the prediction of sequences for speech recognition or machine translation and so on. So in these cases, we're basically making predictions for a particular input. So for a sentence or for an essay or for a person's speech. On the other hand, we can also use generative AI to create new content based on some instructions, as I mentioned earlier. So we can create, for example, a piece of text or an image or artificial voice or a video. So these models are not intended to make predictions on an output, but rather they are technologies that allow us to create new things that didn't exist. So we can also have a look at how AI and all these tools can be used for language teaching and assessment, and I'm sure that you are very familiar with many of them. So one common use is to use generative AI, for example, for personalized learning. So in this case, we could create content that is tailored to students' needs. They can also use generative AI to get feedback on their writing, for example, and use other technologies like learning apps, for example, to learn things at their own pace. In terms of automated assessment, for example, and feedback, students can get also instant grammatical corrections as well as assessment, for example, of their productive skills, like speaking and writing. And they can also use virtual tutors, for example, that provide constant learning support and more realistic practice tasks. But these models can also help other stakeholders, for example, by allowing them to generate new content, for example, creating new tasks and speeding up the test design process, for example. And finally, we could also mention models that can help derive insights from vast amounts of data. So these would be systems that would analyze, for example, large volumes of data and identify patterns and issues that can help with policy making or decision making. So here I have attempted to show you how different capabilities can benefit different stakeholders. This is roughly what I just mentioned. In general, we can see that students can mostly benefit from capabilities related to feedback and adaptive content, while teachers can benefit from content creation and automatic grading. Then schools, for example, can benefit from cost saving and resource allocation. And finally, governments and decision makers, policy makers can use AI to get help with strategic planning. Now, just like I mentioned the things that AI is good at and we can use it for, there are also some things where AI can't help us, and cases where we shouldn't be using AI. However tempting it might be to try to automate everything using AI. So, for example, we have to be aware that AI is not a replacement for human interaction. So despite all the benefits of interacting with AI systems that we could mention, AI systems are simply not a replacement for humans because they don't have emotion, they don't have empathy or agency, they can't make decisions. So they should be used to complement rather than replace human tutors. Also, they can't understand social cultural context or subtleties of human communication, and also they shouldn't be used to make ethical decisions. So anything that involves making ethical decisions should sit on humans. So humans should be in control of ethical decisions surrounding AI. And what this means in particular is that we should always make sure that we have a human in the loop and there's constant monitoring of these systems. So now that we have some basic notions of AI models and how AI works and so on, let's move on to the other aspect of this AI literacy that I mentioned earlier, and that would be the skills that we need to evaluate how suitable AI models are when we want to use them. So what dimensions should we take into account to evaluate an AI system? So I have included 6 here: fit for purpose, performance, ethics, usability, cost, and impact. And I'm sure that you can probably think of many more. I just think that these are at least the most basic ones that should give us a very good start. So I have tried to characterize each dimension by the kind of questions that we are seeking to answer in each case. So, for example, in the case of evaluating whether something is fit for purpose, we should see whether the system does what it should, whether it does what we need, then how well it works, does it meet minimum ethical standards, is it intuitive to use, how does that integrate into systems that we might already have, is the cost of running the system within our budget, is this going to be scalable, and finally, what kind of impacts will the system have and the outputs of the system have on the environment and our context. Now, all of these dimensions required a lot of detailed analysis, but given time constraints in this talk, I will only focus on 2: performance and ethics. So when we talk about performance, what we're aiming to do is to collect evidence, objective evidence of the capabilities of the model. We want to have numbers that can help us assess if a model is good enough for our purposes or not. Now, for each type of task that we might want to solve using AI, we will have to find an appropriate evaluation metric that are, in general, metrics that are standard in the field. So we have to identify these metrics and use those specific metrics to evaluate the model. So, for example, if we want to evaluate the performance of a speech recognition model, we will use metrics such as word error rate, If we want to evaluate an automated scoring system, we could use measures of agreement or measures of error and so on. So it's important that we make sure that we use the right metrics for the right tasks. And also, there are many benchmarks online. There are many public data sets that can also help us compare the performance of a particular model to state-of-the-art models, for example. Something that we have to take into account is to always push for the objective evaluation of models and don't settle for blanket statements that say things like, oh well, this model is good enough, or yeah, I've tested it and it's very accurate. We always have to ask suppliers to give us objective evidence of how their model works on existing data sets, for example. Now, for many public access models, there is information online about their performance. So that information is usually publicly available. And in the case of LLMs in particular, many companies actually publish their own benchmarks, but there are also many research communities that carry out and publish their own evaluation experiments. But in any case, whether this comes from their own companies or research communities, if you are planning to use LLMs, I think it's a great idea to search and look out for these benchmarks and find the LLMs that are the most suitable for your particular use case. So it might well be that one LLM is very good at generating prose, for example, but is really bad at generating programming code. So I would encourage you to always use the LLM or generative AI tool that is the most accurate for your particular use case. Now, when it comes to ethics, we also want to make sure that our AI models meet minimum ethical standards. So if they don't meet those standards, there is a risk that we can suffer reputational damage, and we could even have face legal consequences. So to carry out an ethical assessment, we can use one of the many ethical frameworks from well-known organizations, such as the EU or the UN. Each of these frameworks defines their own set of principles. But for this talk, I've tried to summarize the ones that I think are mostly shared across these frameworks. So this is a list of the most common ethical principles that I think we should take into account when using an AI model, regardless of whether we are developing the model or whether we are using this as end users. So let's have a look at each of them. So the first one, transparency and explainability, requires that we are transparent about the use of AI to end users and can explain how the models produce their output to the extent possible. Fairness and non-discrimination refers to minimizing biases that could disadvantage specific populations. Privacy and data protection ensures that privacy is preserved, that private data is used responsibly and also according to law. Accountability and responsibility makes sure that there is a responsible human behind the system at all times. Safety and security refers to the safe storage and use of information. Human autonomy and oversight make sure that there's a human in the loop at all times, and there's somebody that monitors the system and can step in if necessary. No harm ensures that the system is not used for evil purposes or to create misinformation, for example. And finally, sustainability looks at the impact of the system in society and the environment. A big part, I think, of the commitment to ethics is to obviously do our best to minimize the risks in each of these dimensions. And the way that we do that is by taking measures such as implementing technical solutions or doing regular ethics. So on this slide, I've tried to summarize the main mitigation strategies that we could use for each of these ethical dimensions. But I would suggest that you anyway refer to existing guidelines to build a more comprehensive risk mitigation plan. Now, the last thing that I wanted to mention about model evaluation is the so-called model cards or system cards. So these are documents that provide information about a model, such as its intended use, how it was trained, how it was tested. It often includes performance metrics, so the kind of metrics that I mentioned earlier, its capabilities, limitation, ethical considerations, and so on. So in a way, they are a good summary of all the kind of information that I recommended that we should collect to evaluate systems. So they are documents that can actually save us a lot of time and effort. So you will typically find model cards for most public AI models, but I also recommend that if you decide to use models created by private companies, you also reach out to them to ask for these model cards, because they will simplify your evaluation greatly. So we've learned about the foundations of AI. We also seen how we should evaluate if a model is fit for purpose or not, and whether it's safe to use it. So now comes the fun part, where we actually use the model for our intended purpose. Now, I will not bother you by repeating all the use cases that I've already mentioned and that you probably already know. So instead, I'd like to show you some examples of how AI has been successfully used for different cases, different use cases. So in this slide, I included 5 success stories. So in the first case, we see, for example, how a learning assistant with high precision can be used to help students who get stuck during learning. In the second case, we see how a system that predicts grades can warn students and save them from failing. We also have an example of how adaptive learning systems can maximize student performance and lead to high scores. The fourth case shows how an automatic scoring platform could, for example, free up to 70% of teachers' time by doing automatic grading. And finally, I included a case where a chatbot could resolve student queries with 91% accuracy, which is very, very high. So you can see how we can use different AI models successfully. Now, even though we love all our stories to be like these ones, there are actually many cases of AI going wrong and AI being used in a wrong way. So in this next slide, I would like to show you some of horror stories, things that have gone wrong when using AI. So in the first case, we have the case of a chatbot, for example, that was designed for schools that failed for multiple reasons. So on the one hand, for example, that particular chatbot never seemed to have worked well. But on the other hand, the company that was building that chatbot also financially collapsed. So that raised a lot of issues around the transparency of the company, the use of private data, the quality of the model, and so on. In the second case, that's, well, the famous A-level fiasco in the UK during the pandemic, where students' grades were estimated using a biased algorithm, an algorithm that was basically biased towards students from unprivileged backgrounds, so that they got consistently lower scores. And finally, we have the case of an auto-scoring system that was vulnerable to cheating, to gaming, and so was exploited by students to receive unfairly high marks. So as you can see, if we don't carry out proper assessment of our models, we run the risk of becoming another horror story. So it is crucial that we take model evaluation seriously. I would also like to mention that any solution that uses AI models must also comply with the law. So depending on where you are on where you're planning to use your models, you might need to adhere to national and international legislation, such as GDPR, which is the EU data protection law. So make sure that you always comply with the law and seek expert legal advice if you are in doubt. So now, after this kind of speedy journey through the responsible use of AI, I would like to finish by proposing a small exercise to put all that we've learned today into practice. So this might be more of a self-reflection exercise, because I'm not sure if all of you can use the chat. But I think I'd like to show you 3 scenarios and make you think whether you would agree to use AI in each of those cases or not. So let's start with the first scenario, and you can say yes or no in the chat window. So let's imagine a scenario where a language assessment company wants to use AI to create adapted tests that adjust the difficulty of the questions based on the test takers' performance in real time. Is this a scenario where you think it would be wise to use AI? It would be a good idea to use AI? Yes. Yes, that's the scenario where it would be good to use AI, and we can see many examples in international examinations, some companies that use this kind of approach. A second scenario, let's say a university wants to use an AI content detector to evaluate student submissions and automatically report them for misconduct if the detection is positive. Would you use AI here or not? Would you use it for this purpose? Okay, so mostly no, some yeses. So no, I wouldn't recommend using AI in this way. Why? Because many of these detectors are not foolproof, so they are not perfect. So if we have an automatic reporting system, we might be accusing many people unfairly. So that could lead us into trouble. So better to avoid this use. And finally, the last scenario. So let's say that in order to minimize time and costs, a government wants to implement a fully automated AI-graded language test for immigration purposes. What do you think? Would it be a good idea to use AI for this? Okay, so I see mixed opinions. So I wouldn't recommend to use AI in this case, and in fact, this goes against some ethical principles. This is mainly because we're making high stakes decisions in a fully automated way. So this is something that we shouldn't be doing. As I mentioned earlier, we shouldn't delegate ethical decisions on machines alone. So that's all from me. I might have taken it too long, maybe. So I am happy now to answer any questions and initiate maybe some discussions. Thank you very much.
Thank you very much, Mariano. That was fantastic. Yeah, we have maybe just like 1 minute or so for questions. We do have one from Hugh Williams in the chat, which I will put to you now. I don't know if you can see it. And Hugh says, in the context of foreign language learning, What are your thoughts on the capabilities of speech to text, or OCR, when used as an input for an NN in automatic scoring models? I guess that means neural network.
So I think we're talking about the capabilities of ASR models to be good models for non-native speech. Well, they tend to work quite well, but these are general models. So ideally, we would like to use very specific models that have been trained on representative samples of non-native speech. And also, for example, if we are looking at specific populations, we might want to have models for specific populations as well. For example, children, not adults. So yes, this is something that we have to take into account. Some, general systems might work fairly well, but they are not ideal.
Okay. Thank you. I just got one more. I think we've just got time for one last one from Rosella, who asks, while the socioeconomic divide is supposedly narrowed down by digital access, nowadays the monetization of digital services perpetrates the same divide. Do you have any recommendations towards effective and open access AI platforms or tools that teachers, particularly in third level countries, can use? So in a cost-effective way, I guess.
Well, there are many open source and public models that could be used, but I essentially think that governments play a big part in narrowing this divide. So, although there's a lot that we can do ourselves by using free tools and open source tools, I think it's probably the powers that be that need to make sure that this divide doesn't widen.
Okay. Thank you. Thank you very much, Mariano. I am just going to share a couple of things just before we go. I hope that you can see my screen. So this is just to show that you can register for the next webinar. We have 2 more webinars in this series, one at the beginning of October, one at the beginning of November. And you can also check out the conference information and find out more about the conference in November. We hope to see lots of you there. If you would like a certificate for today, then please do our survey, and I hope the link for our survey is going to be in the chat just now. Has that gone in there? Yes, we've got that. Thank you very much. And also you can sign up for our mailing list as well to find out more about the conference. And just finally, this is how you can sign up for our next webinar. Our speaker is from Chulalongkorn University, and the topic and the details are to be confirmed, but you could sign up now and make sure that you get that in your calendar. We would love to see you at the next webinar. And that is all from us for today. Thank you very much for joining us and for your participation in today's webinar. Thank you once again very much to Mariano for a great talk and lots of food for thought for everyone. And we hope to see you again, all again at the conference and at the next webinar as well. Thank you very much and enjoy the rest of your day.